Let us understand the concept of limit by taking some examples. If we take limit when x approaches 0 sin x, that is LHL limit x tends to 0 minus, as you have already notified this notation, sin x, limit h tends to 0, and in place of x we will write 0 minus h. So limit h tends to 0 sine of minus h, that will be equal to limit h tends to 0 minus of sine h. Now if we put the value of h in the function will become sine 0, that is 0. Similarly, for RHL of this function, limit x tends to 0 plus sine of x, limit h tends to 0, and in place of x we will put h, 0 plus h or h. Now limit h tends to 0 sine of h. So after putting the value of h in the function, we will get sine of 0, that is equal to 0. Hence here LHL equal to RHL. Since the left hand side and the right hand side of the function is equal, so the limit of sin x when x approaches 0 exists. Let us consider another example. If we consider f of x equal to x square minus 4 upon x minus 2, and limit x tends to 2 f of x. Here if we approach the value of fx, if we approach x towards 2, the value of fx will be fx approaches to 4 when x approaches to 2. From the left hand side it approaches 4, and from the right side it also approaches to 4. But at the point x equal to 2, f of x is not defined, at x equal to 2. Hence we cannot talk about the value of f of x at x equal to 2, but certainly we can consider left hand side limit and the right hand side limit of the function at x equal to 2. So as we have already discussed about this, when a certain function approaches a certain value, then the limit exists. It doesn't matter whether at that point f of x exists or not. Here LHL of this function, limit x tends to 2 minus x square minus 4 upon x minus 2. So limit x tends to 2 minus x plus 2 into x minus 2 upon x minus 2. This will be cancelled out, and the final value of this will be limit x tends to 0. In place of x we will put 2 minus h plus 2, that is equal to 4 minus h when limit x tends to 0. So the value is 4. Similarly, RHL for this function, limit h tends to 0 x plus 2. In place of x we will put 2 plus h plus 2, that is equal to limit h tends to 0 4 plus h. So the final value is 4. Hence LHL equal to RHL, and that's why the limit exists. Despite the fact that at x equal to 2 the function does not exist, the function doesn't have a certain value, the point x equal to 2 is not in the domain of the function, but limit of this function exists since left hand side limit and the right hand side limit are equal. Let us consider another example. F of x equal to x by x. So here domain of f is r minus 0, so we cannot take 0 in its domain, but limit x tends to 0 f of x is equal to limit h tends to 0 h upon h, or if we consider this as the left hand side limit, this will be 0 minus h upon 0 minus h, hence limit h tends to 0 minus h upon minus h, that is equal to 1. Similarly for RHL, limit x tends to 0 plus f of x, limit x tends to, or we can write h tends to 0 and f of 0 plus h, so limit h tends to 0 0 plus h upon 0 plus h, that will become limit h tends to 0 h upon h is equal to 1. Hence limit left hand side and the right hand side of this function exist and they both are equal, hence limit of this function f of x exists. That's all. Thank you.